Hello students, welcome to IMS GATE Academy. In today's session, I am going to start small signal amplifiers. In the last class, I did the topic of regulators by using bipolar junction transistor. Today, I would like to discuss about the small signal amplifiers. What are the models are there? I will explain, and I will select certain number of the models, and I am going to explain here now. Yes, the topic is small signal amplifier. Small signal amplifier. Amplifier. By using BJT is one. But in this case, in this particular topic, the amplifier will be given a small signal as an input. That voltage will be very, very small. For the sake of increasing the gain, we are going to use the small signal amplifiers. But to do the analysis in the small signal amplifier, different techniques are applied. One is nothing but H parameter model. Second one is nothing but approximate H-model. Third one is RE model. The fourth one is R-pi model. By using these models, you can determine the input impedance or output impedance or voltage gain or current gain. Any one of the parameter we can find. In the gate, mostly we can expect voltage gain. How to find out the voltage gain from the given network, you will see now, understand now. Anyhow, I want to say the following four methods are used. The following methods are used better. Methods are used to find input impedance, to find the input impedance, you can use this method. Otherwise, to find the output impedance, you can use this method. Output impedance. Even you want to find out the voltage gain, you can use this method. Voltage gain also, you can determine. Voltage gain. Even you want to find the current gain, you can use this analysis. And current gain. So what those techniques are used? Just now I said, you can use H parameter model. H parameter model you can use. Otherwise, you can use approximate H model. Approximate H model also you can use. And third one, you can use RE model. And the fourth one is nothing but R-pi model. These are the models are used to find the different parameters. But here initially I wish to select the H parameter model. I wish to select H parameter model initially. H parameter model. But in this model, I would like to explain how to draw H parameter equivalent circuits. Then after, I will give formulas related to the H parameter equivalent circuits. But from the networks, everybody knows what are the H parameters. How we can write H parameters from the network? H parameter equations are, we can write like this. H parameter equations are, how you can write? V1 equal to H11, V1 equal to H11 into I1 plus H12 into V2, it is taken here now. V1 equal to H11 into I1 plus H12 into V2. And I2 equal to, we know very well from the networks, H21 into I1 plus H22 into V2. These two are to be taken as a H parameter equations. But a H11, H12, H21, H22, we are generally using in network analysis. In the analog circuits, we are not going to use the same symbols. With a slight change, it is taken here now. Their HI is taken for the H11. We are going to use the symbol HI instead of H11. Wherever H11 we got, the drive is to take it as HI. The name given for this HI in the analog circuit is input impedance. It is given name. Input impedance. HI equal to H11 only now. What about H12? That H12 is given a name of HR. Because H11 equal to V1 by I1. Voltage by current equal to impedance only. Input voltage by input current when V2 is 0. That is nothing but input impedance. H12 is required means I1 is to be made 0 only. If it is made 0, H12 equal to V1 by V2. V2 by V1 means we can say forward voltage gain. V1 by V2 means we can say it as a reverse voltage gain. That's why H12 is given a name of HR. So we can write HR equal to H12. That's given a name reverse voltage gain. Reverse voltage gain. Such a name is given. When I1 is 0, I will get reverse voltage gain. What about H21, sir? H21 is required means you need to put V2 equal to 0. In that case, H21 equal to I2 by I1. I2 by I1 means we can say forward current gain. I would like to put a symbol of HF. H suffix F, I want to put the symbol. That equal to H21. I2 by I1 when V2 equal to 0. It's given a name forward current gain. Forward current gain. It is given a name. And still left H22. H22, if you want to get I1 is to be taken 0 only. If I1 is 0, H22 equal to I2 by V2. I2 by V2, current by voltage is nothing but admittance. Is it input admittance or output admittance? Output admittance is possible because output current by output voltage we have taken. So that is given a name H0. H0 equal to, I can write H22. That equal to output admittance, it is given name. Output admittance. Such a way name is given here now. Output admittance, it is given. So these are the symbols HI, HR, HF, H0. I will put in the place of H11, H12, H21 and H22. Now the given H parameters you can rewrite in this way. How we can rewrite? I'll write now. V1 equal to H11 into I1 I gave it. H11 is nothing but I have taken HI into I1 plus H12 equal to what I gave it already. H12 is nothing but HR. I can write here now HR into V2 we can put now. HR into V2. And one more equation I gave it I2 equal to H21. I gave H21 is nothing but HF. I can write HF into I1 plus H22 is nothing but H0 I gave it. Output admittance I gave it. H0 into V2. Yes, we got two equations like this. These are the two equations we are getting here now. By using these equations, we need to draw H parameter equivalent circuit. How we can draw? The first equation is nothing but the voltage equation. V1 equal to some voltage plus some other voltage. So, voltage equation is given means you can form Thevenin's equivalent circuit. Thevenin's equivalent circuit we can form. The second one is nothing but I2 equal to some current plus some other current. Current equation whenever you are given, you can form Norton's equivalent circuit. Norton's equivalent circuit we can write. How we can form? Input side V1 is there. I will connect with V1 here. This is V1. This voltage is equal to this voltage. HI is nothing but input impedance. HI I have taken here now. Because of the connection of the V1, it is going to flow current of I1. This current I want to denote by symbol I1. So, I got V1 equal to HI into I1. Yes, V1 equal to HI into I1 plus HR into V2. This is nothing but the what input circuits. The input circuit depends upon V2. V2 means output voltage only. Whenever the input circuit depends upon the output voltage, we need to take one dependent source here. Here required one dependent source. Is a plus minus. Its value will be taken as a what? HR into V2. HR into V2 we have taken. Yes, now equation is exactly satisfied. V1 equal to HI into I1, yes, plus HR into V2 we got. But output side we got the what now? One more circuit, that is nothing but the Norton's equivalent circuit. Norton's equivalent circuit means we need to have the current source. This side I can put the current I2. The current I2. This current equal to this current plus this current. This current how I can take? That means the current is divided into two paths here now. That's why two currents we are getting here now. I2 is divided into two paths. That means two parallel paths are required. One is nothing but H0 into V2. H0 is nothing but output admittance. Reciprocal of the admittance is nothing but the impedance only. I can take, this is nothing but 1 by H0. 1 by H0 indicates impedance only here now. The voltage across this I want to take it as a V2. This is a V2 I have taken here now. Now please watch. I2 equal to, yes, this current, what is the drop across this? What is the current passing through this side? V2 by 1 by H0. V2 by 1 by H0 is nothing but V2 into H0 I am getting here. And one more current is passing through other path. This is nothing but output circuit is dependent upon the current I1. It depends upon the input current I1. So, we must take one dependent source here. It's a must one dependent source. That current is nothing but HF into I1. HF into I1 I can write. Finally, we are getting the what now? That means this is we are getting now I2 equal to V2 into H0 plus HF into I1. This is said to be H parameters equivalent circuit. H parameters equivalent circuit. Equivalent circuit. But in the problem, we will give HI value, HR value, HF, H naught. By using these parameters, we need to calculate different gains. Different gains we need to find. What are the gains? I will give the now. Current gain or voltage gain or whatever it may be the now. But you will ask sometimes current gain. Current gain formula means what formula you can use for the current gain in H parameter model. Current gain. The current gain is calculated, that is given a symbol of AI. Current gain equal to A suffix I. Current gain is calculated by minus HF divided by 1 plus H naught into RL. By using this formula, they will determine RL is the load will be connected here now. When the load is given in the problem, you will get. But these are the formulas are common only now. Whether it is a common emitter configuration or common collector configuration or common base configuration, it doesn't matter now. For any configuration, these formulas are applicable now. Understand now. To find the current gain, the formula is applied. If you want to find the input impedance, to think it so. To find the input impedance, you must apply the formula. Zi equal to Hi plus input impedance, Hi plus HR into AI, into RL. This formula is applicable. To find out the input impedance, Hi plus HR into AI into RL. That formula you need to apply. But in case you are asked to find out the what no? Voltage gain. Voltage gain, if you want to find, you must use this formula. For voltage gain. Otherwise, I will write in the next page best. To find the voltage gain, you can use one more page. If you wish to find the voltage gain in the problem, you need to use this formula. Voltage gain. This is the given symbol of AV. That AV is calculated by AI into RL, current gain into load resistance by Zi. We know how to find out the Zi, already given. What formula is given? Zi. Zi equal to already given, Hi plus HR into AI into RL, same formula. By using this formula, Zi you have to compute only. And what about the output admittance? To find the output admittance, you must use the formula. What formula I will give now? Y naught is the output admittance. To find the output admittance, it is applicable formula H naught minus HF into HR, divided by Hi plus RS. RS is nothing but the what now? The source resistance only now. The source has got any internal resistance, that is to be taken RS. Source resistance only we can put it now. Understand now. So H naught minus HF into HR by Hi plus HR. So these are the formulas we are going to use to find out the. But in the same way, output admittance means this only. Output impedance means reciprocal of this admittance, you know very well. In case you are asked to find output impedance, if you are asked to find the output impedance, that is given as Z naught. Z naught is nothing but a reciprocal of the admittance only now. So these are the formulae you must know to do any problem. Direct formula application. Just I want to do one problem by using H parameter model now. By using the H parameter model, I want to do one problem only now. That problem is find AI is asking to find the current gain. Find current gain. It is given a symbol AI and ZI. Input impedance also required. AI and ZI values are required. For HIE equal to IE, E indicates common emitter configuration. B given means HIB, common base. HIC means common collector configuration. HIE is given in the problem 1K, 1 kilo ohm it is given. And HRE is given, HRE, reverse voltage gain is given 1 into 10 power minus 4. 1 into 10 power minus 4 it is given. That is HRE value. And HFE is given, forward current gain is given 50, 50. And HOE, output admittance is given. Its value is nothing but HOE is given 100 micro mho is given. And RL is given 10K, load resistance is given 10K. And RS is given 1K. This input source contains the resistance of, internal resistance of 1K, RS is given, source resistance also given now. But how we can find these parameters? What those parameters are required? Current gain is required and also input impedance is required. Directly you can use the formula. Directly you can use, understand now. But how we can do this problem? Please watch, I will do this question. If you wish to find the current gain, you need to use the formula directly. AI is required. But already I gave the formula for the current gain minus HFE by 1 plus HOE into RL. HOE into RL. This is the formula I gave for the what now? Current gain minus HFE by 1 plus HOE into RL. You can substitute these values. What are those values are given? Minus HFE is nothing but, it is given as a 50. Divide 1 plus HOE. HOE is nothing but the 100 micro, 10 power minus 6. RL is given 10K, 10 into 10 power 3 is given. But you can simplify this. Current gain is nothing but minus 50 by 1 plus, it is a 10 power 3, 10 power 3, 10 power 6 and 10 power minus 6 means both are cancelled. Finally, we are going to get 1. Minus 50 by 2 is nothing but minus 25. So, we are getting current gain is nothing but minus 25. And also is asking to find the input impedance for this common emitter configuration. The input impedance is denoted by a symbol ZI. ZI equal to, already I gave HIE plus HRE into current gain AI into RL. AI into RL I gave it. That formula is given already. Direct substitution. We know very well what is HIE. HIE is nothing but 1K. I can write 1 into 10 power 3 plus HRE is given 1 into 10 power minus 4. 1 into 10 power minus 4. I can write. Current gain AI is nothing but minus 25. Minus 25 is given. And the RL is given 10K. In the problem directly given 10K. I can put 10 into 10 power 3. On simplification, I will get input impedance of ZI. The ZI will be 999.99 ohms mostly possible. This is the answer is possible. But I think one problem is just enough by using H parameter model, because direct formula application in this model, understand now. Now I would like to enter into approximate H model. There I will do the some work, then after I will start the problems based upon them. Next one is approximate H-model. The next model I want to take approximate H-model. H-model. How that model will be applicable? But we are doing the H parameter model when you are given all H parameters, HI, HR, HFE, HOE. All the H parameters are given means you are applying the H model. Approximate H model you will apply when you are given HIE and also HFE. Only two H parameters will be given now. When two H parameters are given, you need to apply the approximate H model now. But already I gave H parameter equivalent circuits. By using that circuit, I will get the approximate H model. Then after I will do the work on what now? The formulae which are used in gates that I will derive also. Understand now. Approximate H model, when you want to go means, but I gave already H parameter model, I gave already network like this. This is a V1 I gave already. This is nothing but HI I gave already. The current passing through this I have taken I1 already. And also I have taken here now input contains one dependent source. I said already that I want to connect. This is a voltage source I said now. HR into V2 already given. This is nothing but HR into V2 I gave it. The output circuit is with Norton's equivalent circuit. Here we can have one current source, there is a dependent source I gave already. That is nothing but HF into I1 I gave it, HF into I1. And here I gave one more path. This is 1 by H0 I gave already. This current is a I2 I gave already. The voltage across these two terminals I gave V2. This is nothing but I said H parameter model, H parameter equivalent circuit I said already. Equivalent circuit already given. We know very well this. We know very well this. H parameter equivalent circuit. When approximate H model, slight change you will find in the circuit. Here HR is nothing but reverse voltage gain. But a forward voltage gain is nothing but V2 by V1. Forward voltage gain is always available, larger value. It comes in hundreds only in common emitter configuration because practically we are using common emitter configuration. There you can find the reverse what now, but V2 by V1 forward voltage gain very large in hundreds. HR is nothing but the reverse voltage gain. 1 by a larger value equal to very smaller value is available. Smaller value means that HR value we are going to neglect. Its value is a very small. So what I wish to say, whenever this HR value is neglected, approximately it is taken 0 value, this total voltage becomes 0 only. HR is taken approximately 0 because 0 point something it comes around. At the time this voltage became 0 means it must be shorted only now. This must be shorted. I can say in approximate H model, there is V1, HR reverse voltage gain, its value is a very small, it is approximately equal to 0 we have taken. So 0 into V2 0, it is a short circuited only now. That HI I want to shift to this side. It's not a mistake, even you shift it to the position here now. Its value I want to take it as a HI. This I want to take it as a HI. This current I wish to select as a I1. This is I1. And one more point you need to understand. H naught is nothing but the output admittance only. Admittance value is always very, very small practically. Admittance value will come very, very small. 1 by very smaller value, 1 by very smaller value will be very large value. That means the total resistance becomes very large value. Whenever the resistance is very large, it can act just like a open circuit only now. So 1 by H naught is very large. That is why it can act as a what? Open circuit, I can say. So I can draw this diagram like this. This current source is existing. This is the dependent source we got here. This is taken as a HF into I1. And the resistance is very large, that can act as an open circuit, I said here now. Finally, we are going to have this network. This voltage we can have here now. This can be taken as a what? Approximate H parameter equivalent circuit. So this is said to be approximate H-model circuit, H parameter equivalent circuit only. Now, by using this approximate H parameter circuit, I want to find different parameters now. What those parameters will be useful to do the problems only now. You watch now how I will give the formula. Suppose I am asking the question, one question I will give, then you can understand clearly. Find Zi, I want input impedance. Also required output admittance, I asked. Output impedance I want. Input impedance and output impedance. And also I want voltage gain, AV, using approximate H model. Approximate H model I said, by using approximate H model. But I want to give this circuit in your hand now. How that circuit will be there? The question is given like this now. The circuit is given like this. There is a resistor, that is RC. This is VCC. Here connected with a emitter resistance, RE. There is a bypass capacitor. This is nothing but CE. Here connected with a capacitance of the capacitor with a load, RL. The output I want to get from this point. Here voltage divider biasing is connected here. This is R1, this is R2 here connected. First with non-numeric. The circuit with a non-numeric I am giving here now. Then after numerical values I will give, you can find voltage gain or whatever it may be now. Here connected with one capacitor with source VI. This is the given problem. This is the given problem. But how we can find Zi, Z0 and voltage gain? How to get it now? We need to draw approximate H model equivalent circuit. Once you have drawn that circuit, it becomes very simple to find any parameter. So we should know that point very well. How we can draw? The point number 1. Whenever this is the approximate H parameter equivalent circuit, whenever you want to apply, we are drawing the AC equivalent circuit only here now. Under AC analysis, wherever the DC source is given in the network, wherever DC source, there is a voltage source, DC voltage source is given, that must be shorted. Try to understand. Wherever the DC voltage source is given, there is short circuit. In case any current source is given, you think it's so, that must be open circuited. All DC voltages are shorted, current sources are open circuited. Wherever capacitor is given, that must be shorted under AC analysis, because we are applying the AC analysis only. That means what I said, Vi must be connected to the what? Ground. This is connected to the ground. Yes, I will connect Vi to the ground. I want to connect Vi to the ground. Vi to the ground. Here connected. I connected to the ground one. This capacitor must be shorted under DC analysis, under AC analysis, sorry. Wherever the DC voltage source you got, you short circuit, I said already. So R1 is connected to the ground. Yes, R1 is connected to the ground. I can drop. That we can connect to the down also, R1. And here R2 also connected to the ground. I can connect R2 to the ground. This is also connected to the ground. After that, we got one transistor. Wherever a transistor is given, that's my point. If you are given any transistor, you think it's so. In the H parameter equivalent circuit, you can draw like this now. One resistor with current source. Just now I have drawn approximate H parameter circuit, same circuit. This is a must. In the approximate H model, I have taken this is a HIE, I gave it. This is nothing but the what now? Current source I connected here now already. That circuit we can connect now. In the place of the transistor, what do you have to put? In approximate H model, you have to connect one resistance. That is to be taken as a HIE. That resistance is taken HIE. The current is not, what current is passing this side? Base current is passing. There we have taken I1. Here to be taken base current IB. Small letters you try to use in AC analysis. I suffix B is passing this side. HIE, and also you must connect with a current source. This current source depends upon this current. There you have taken I1. It depends upon the base current here now. It depends upon the base current now. But this I gave it HFE. It is a common emitter configuration. That's why we are using E. HFE into IB. I can put here now. IB. HFE into IB. Because the base current in the place of I1. Next, when this DC source is grounded here now, RC also connected to the ground. Yes. RC also connected to the ground. Still what you have here now, capacitor is shorted and load is connected to the ground. Yes, this is connected to the ground. RL is connected to the ground. This is nothing but V0. This can be taken as a V0 value. This is the emitter point. This is the emitter point. Here the capacitor is shorted here now. RE is connected to the what now? One shorted wire only here now. At the time what happened now? Zero resistance only possible. 0 into RE by 0 plus RE. 0 only power. So here I can get, this is connected to the ground only. This is connected to the ground. Finally all these ground points can be connected such a way only. But in the problem is asking to find what is Zi, what is Z0, what is the voltage gain is asking. When the view is made, that's my point. When the view is made in this direction, you will get what is the input impedance. When you made the view in this direction, you will get H0 value directly. You will get the H0 value, Z0 value, sorry. Z0 value, this is Zi value now. But I can give directly what is Zi here now. R1, R2 and HIE are connected in parallel. The parallel combination of these three will give the Zi. I can write directly here now. Zi can be calculated by R1 parallel to R2 parallel to HIE. This formula you can use to find out the input impedance. When they are in pair, three resistors are in parallel, you know the formula, you can apply directly now. The next one, output impedance, if you want to get, RC and RL are in parallel. But output impedance, if you want to find, means condition is there exactly. What condition? Wherever the input voltage source is given, that's my point. to find the output impedance, input voltage source is to be shorted. Input voltage is to be shorted. And output terminal is connected with a source. One source we have to connect only now. When input voltage is shorted here now, what is going to happen now? We don't have any voltage source input side. In that case, what current will pass in the input? We cannot find any current because we don't have any voltage source at the input level. We cannot find any current in this network only now. At the time, base current is going to become 0. Followed or not followed? But as per the condition, to find the output impedance, input voltage source is to be shorted and output terminals must be connected with a voltage source only now. When input voltage source is shorted, we cannot find any voltage source at the input side. At the time, the base current is going to become 0. When the base current is 0, IB is 0, 0 into H of E totally 0. This current becomes 0. Whenever this current is 0, this can act as a what now? Open circuit only. And finally, we are going to have only 2 resistors only. What those 2 resistors? RC and RL are in parallel. Otherwise, not followed means very simple. Z0 means RC parallel to RL. Directly you can use, you can get answer now. So I can say Z0 is calculated by RC parallel to RL. You know formula RC into RL by RC plus RL, you can use the now. But like that Z0 and what now? Like that we can find Zi and Z0. But what about the voltage gains are? Voltage gain, if you want to find, initially you find what, but this total resistance is nothing but Z0 I have taken already. HFE into IB is the current passing through the Z0, is the current passing through the Z0 this side. The V0 is nothing but voltage across the Z0. To find the voltage gain, I wish to find V0 at first. The V0 equal to what I said, but the mostly what a load has to receive the current, but the current is in reverse direction. Current is in reverse means this current is to be taken with what? Minus sign only now. So current into impedance is nothing but the V0 minus H of E into IB into Z0 I can use. But how to find the Z0? You know, RC parallel to RL. You can use that formula only. Then what is IB here required to find out the voltage gain? What is the base current? This is the base current now. But these are all connected. R1, R2 and HIE are connected in parallel. So voltage, but whenever these are all in parallel, voltage will be same. It won't be default. So voltage across HIE can be taken as the same VI. I can take this also VI only. Same voltage you can have. So I can get the IB is nothing but VI by HIE. I can write IB equal to VI by HIE. I can write VI by HIE. Now I can substitute here now. V0 is nothing but minus H of E into IB is nothing but VI by HIE into Z0. My aim is to find the voltage gain. Voltage gain is nothing but V0 by VI. V0 by VI. V0 by VI equal to what I can get? Minus H of E into Z0 divided by HIE. By using this formula, you can find the voltage gain. Now, I would like to give certain number of the problems based upon this concept. Most in the GATE exam, you can find questions on voltage gain. So, I will give 2 problems based upon that one. The first problem I will give now. The problem is given like this. Find AV. AV is nothing but the voltage gain. Find AV. If H of E equal to 100, 100, HIE equal to 1K. HIE equal to 1K is given, 1 kilo ohm. 1 kilo ohm. And here given network like this. This is RC. RC is given 3K. This supply voltage is given VCC. RE is given 1K. There is one bypass capacitor C, and there is a capacitor. This V0 is taken here connected with a load. That load is given here 3K, RL equal to 3K is given. The biasing here given, voltage divider biasing. Here connected with two resistors R1 and R2. The R1 is given 50K and R2 is given here 25K. This is given 25K. There is a capacitor with VI. That is the given problem. This is the given problem. But it's asking to find the voltage gain. But students can get it out here now. Sir, it is not given approximate H model. Then how I can understand whether to apply this approximate H parameter model or not? You tell me. I said already, if you are given HFE and HIE, these two H parameters, you must use approximate H model only now. Because by using these two H parameters only, you will find the voltage gain only now. And also, what I wish to say here now, sometimes what happens now, in the place of HFE, you will give beta. HFE is nothing but the forward current gain, we know. That forward current gain can also be denoted by symbol beta. That's why you will give HFE, or otherwise you will give beta. Beta or HFE both are same only now. Understand? But directly you can use the formula here now. How we can apply formula for this? The voltage gain, I give formula like this. I wish to find voltage gain. The voltage gain AV equal to just now I have done voltage gain minus HFE into Z0, HFE into Z0 divided by what I gave it, divided by HIE I gave already. That formula is given already. Directly you can use. But Z0 equal to, we know very well. I gave the condition already. RC parallel to RL I gave it. Already given. RC is given here 3K. That is parallel to what? RL is nothing but 3K. It becomes 1.5K. 1.5K possible. Directly you can use the formula to find the voltage gain. So voltage gain equal to minus HFE. HFE is given 100. Z0 is nothing but 1.5K. Divide HIE is nothing but 1K. Use calculator, you will get answer. That value will be minus 150 is possible. Minus 150 is possible. So that much amount of voltage gain we can get from this circuit, I can say. This is one of the problem. And I will give same model question one more. You please write. Just formula application only, nothing more. And one more question is given like this. Find AV, find voltage gain AV. If HFE equal to 80 and HIE equal to 1.5K. I am giving 1.5K here, HIE. That much impedance is given. And here the network is given like this. There is RC. The RC is nothing but 4K. Here we given VCC. But here I am not giving any load. Directly V0 I have taken from this point. When RL is not given means Z0 equal to only RC only possible. If RL also given, RC parallel to RL you will apply. Anyhow, this is given like this. Here given RE 500 ohms. There is a capacitor and also here connected with 2 resistors. They can be taken R1, R2 because we are not going to use these values. There is a capacitor with VI. Such a way network is given here now. But we can apply here approximate H model only because you are given 2 parameters beta, there is a HFE 80, HIE input, impedance is given 1.5K. How we can find voltage gain? That voltage gain is calculated by the formula. What formula you can use? The voltage gain is calculated by minus HFE into Z0 by HIE is given already. That formula is given before. HFE into ZI by HIE only now. Z0 equal to what I can put here now? We got only RC. There is no RL. If you don't have the RL, Z0 is to be taken RC alone. Its value is nothing but 4K. That value is a 4K. You substitute here now. You will get the voltage gain. HFE is nothing but 80. Z0 is nothing but 4K. HIE is nothing but 1.5K. If you are using the calculator, you will get minus 213.33 possible. That much amount of voltage gain is possible. With a slight change, I wish to give one question in your hand. Just I will give, you try on your own. I will not give any hint for that. You please try it. With some change, I want to give you a question. The next question, you must complete this question. Find, I am not asking voltage gain, I am asking to find V0. V0 is nothing but the output voltage, is asking to find output voltage. If HIE equal to 3K, HIE equal to 3K, HFE equal to 50 is given. But the given network is like this given. There is a transistor with RC. That RC is given as 3K and supply voltage is given a name VCC. That's given VCC. And here emitter resistance RE is connected here. There is an RE and also there is a bypass capacitor CE. And here connected with a capacitor with capacitor only. V0 is taken here. And here R1 and R2 are given, no values, only R1 and R2. And input voltage is given, this VI is given as, this VI is given 10 into cos of 600T plus cos of 10T. Cos of 10T is given here now. This is the input voltage is given. He is asking to find out the output voltage. You make an effort to get its answer. I will not give any hint. You please try it. That's all for today class. Thank you.